A warm welcome to the session on Datasets for Music Information Research in Indian Art Music by Ajay sir. Ajay sir currently holds the position of Applied Science Manager at Amazon Artificial General Intelligence in Bangalore, India. In this role, he focuses on developing large-scale automatic speech recognition systems for Alexa. Additionally, he serves as an adjunct faculty member in the Department of Heritage, Science and Technology at IIT Hyderabad, India. He earned his PhD in music technology from UPF, where he actively contributed to the COM project. His doctoral research primarily concerned various automatic rhythm analysis challenges in Indian art music. With diverse research interests, he possesses extensive experience in speech, audio, music signal processing, and machine learning. We encourage active participation, questions, and discussions to foster a collaborative exchange of ideas. I now welcome Ajay sir on stage.
Thank you very much, Kavya, for the introduction. Today, I think it's largely an extension of what Preeti ma'am talked about, but more from the perspective of how you would get started working on any of these problems that were discussed. Of course, there is a little bit of bias towards some of the things that I am more familiar with. So I'll try to minimize that as much as possible here. Of course, the field itself is very big, so there might be I will not kind of claim that some of the data related aspects that I'm going to talk about are comprehensive, but then they at least give us a good sampling of the space. So again, please stop me anytime you have questions, anything is not clear, and then let be a discussion, right? I've deliberately not included a lot of references here, just to not clutter the flow, but then if you need references, please write to me. I'll be happily able to share some of them with you, right? Well, largely the content of this presentation are derived from two recent works. One is of course from the monograph on Spark that I think the Spark was a program which ran from 2019 for two years, and then we had Professor Preeti Rao, Professor Hemamurthy, and Professor Mahadev Prasanna driving it. And then the outcome of that was this book. I think it was discussed in the beginning, in the first session. And then one of the chapters in that was called Getting Started on Computational Musicology and MIR and with an Indian music perspective, Indian art music perspective specifically. And then, so this talked about how exactly we can get started with MIR work for India and India-related problems, right? So some of the content is from this book chapter. And then a large part of that is also on with the open data sets that we created. But Saraga, this talks about open data sets for research. I'll go in a lot more detail about the data set, mainly both from the perspective of how we built it and then what it actually contains both, right? So just to kind of go through what we'll do. So I'll just address the problem of why should we get started first, as in what exactly are the motivation challenges that we face. Then try to kind of draw some concepts and parallels in not doing whatever. So just extending on what Preeti ma'am did in the previous session. So talking a little bit more about the rhythmic aspects of it. Then focus in detail about the data sets involved, mainly from the perspective of what are the tenets that we look for when we are building data sets for MIR work, and also talking about how do we build it, how do we kind of access, and then how do we kind of use it. Right? They'll show some examples again of how it was used and then what things are possible. And then towards the end, not completely related to data sets, but then I'll talk about some opportunities that are upcoming, and then what is it possible within the academia and industry currently, right? Yeah. I think this was necessary at the beginning of WiSSAP, but then I'll do it anyway right now. So how many of you are trained in music here? Just a quick show of hands. And trained in Indian music could be, sorry? Huh? Production, yeah, I'll come to production. Well, production also counts. So trained here is, so mostly from a listening perspective, right? And Indian music is both, I mean, folk and art. Yeah, okay, I see a few hands. And Western music, okay, few hands. Production, I see production here. Anyone else in music production? Okay, yeah, few more hands, yes, okay. And anyone can read sheet music here? Yeah. Well, I'm just asking, yeah. Okay, so few, I mean, okay, fine. And avid music listeners, okay, this was a prerequisite to attend WiSSAP, right? Yeah. Okay, anyway, yeah, and of course, I would assume a lot of you are familiar with signal processing and machine learning. So yeah, so that's just to kind of say, see, as technologists, so what we are trying to do is building tools and technologies. That's our core job. But then why are we doing it? So to do all those functions that are there. So it's learn, teach, compose, produce, perform, record, playback, and then consume, analyze, understand, appreciate. So that these are different functions that we could do with music, right? And then that's why we are music technologists. But then this is the definition I use sometimes just to describe what MIR is. MIR is related to these specific functions of music, whereas computational musicology, which is essentially, I'll talk about what it is, right? It concerns itself with some of those other functions of music, right? So, well, computational musicology to start with is a scholarly analysis of music. It's very multidisciplinary to understand music from different facets, right? Of learning, teaching, performance, listening, appreciation, aesthetics, right? But from multiple perspectives. So there are different perspectives here. It could be studied from a historical perspective or cultural or even cognitive, understanding how. And the important distinction, I think, which Preeti ma'am also mentioning, was the use of computational tools for musicology here. And that's where the distinction comes in, right? Then, if we extend this further, there is data-driven computational musicology. So computational musicology does not by itself assume that we have lots of data available to do analysis. But having a lot of data enables us to do corpora level analysis of music. So which is to derive these insights from large amounts of data, and both on all the dimensions that we are usually familiar with, melody, rhythm, and harmony. And it is also expected to supplement and complement manual analysis. So manual analysis brings in a lot of human knowledge into the analysis with lots of experience, human experience, to look for specific patterns. So most of the analysis, because it's manually so intensive, there is a lot of that just is done with smaller data sets. Whereas it could be scaled to a large corpora. So if you want to do musicological analysis on the entire YouTube music collection that we have, so then it's almost impossible for any human to do it, or groups of humans also. So that's when we need to go towards some data-driven approaches. I'm just motivating why we need large data sets that you should all contribute to. And it also can help us verify common knowledge. So there is usually a lot of common knowledge among musicians that kind of talks about certain aspects of music, saying, oh, this is what's happening in this music piece. So how do you derive those insights directly from large collections? Can we go to the society, collect music, and then verify those directly from audio recordings? Which means that we could also use that to derive additional insights that people might not have noticed. But then if we bring that to the fore, people will say, okay, I know this. This is what's happening here. And then it could be useful as well. Right. So why should we do this, first of all, right? I mean, of course, we live in a multicultural world. So we have a lot of different socio-cultural contexts in which music is consumed. And then there is lots of data that's also available. But the challenge is there, it's all copyrighted. Most of the music data that we have is copyrighted. So that's a big bottleneck for MIR. And they are unlabeled. So they are not organized in the way that it is useful for machine consumption. Large collections are organized for human consumption now, but then not for specific analysis. And they are suboptimally organized, suboptimal from the sense of it being useful for specific MIR related tasks that we are looking at. Then the big other opportunity and challenge again is the subjectivity here in creation of these data sets, consumption and analysis. So there is subjectivity, and that's a characteristic and not a bug. So it's a feature, not the bug, not a bug in the entire analysis here. And it's interdisciplinary, which means that we need to bring in people from different parts of the community, musicians, music teachers, engineers, scientists from computer science, scientists from cognitive work. all of them need to come together to build useful data sets here. Okay, and I mean, I think that's where I think the culture-aware technologies came in. So because we wanted to study music cultures within their own cultural context, right? That was comp music. I think it was described in the past as well. The basic three tenets of the project was to actually bring music knowledge into the methods, engineering methods here, and kind of go from music concepts to engineering formulations that could be solved by us engineers, and to involve music communities as we are doing this, right? So that was the three basic ideas there. And then, so that kind of gives you a broad introduction to why we are doing any of this. So the next few minutes, I'll just kind of do a very brief introduction on Indian art music and why it's challenging. I'll not repeat whatever Preeti ma'am said about melody, but then introduce certain few more things about rhythm here. Right. So Indian art music, of course, broadly, it is both, it encompasses Carnatic and Hindustani music. So they have some common concepts in terminology, but then they have differences in practice. Right. Carnatic music, as ma'am had shared a map of subcontinent, it's in the southern part of the subcontinent. It includes the 4 states of Karnataka in the south, plus parts of Sri Lanka as well. Whereas Hindustani music is mostly in the northern parts. Of course, there is a lot of mixing, and then there are some pockets of Hindustani music in the south, and then so on and so forth. So without getting into demographics there, the important thing is they have centuries of evolution with a lot of scholarly analysis done as well, which meant that there are sophisticated melodic and rhythmic structures that exist, and they have been nicely formalized and then studied as well. Right. And then why should we study Indian art music? Well, I mean, of course, they are predominantly oral traditions. So this is more from the perspective of how they are challenging from an MIR perspective. So that's why it's interesting to study them, right? It's different from the way, say, lots of other analysis is done. They are predominantly oral, and then they are sophisticated and structured. So there is a lot of scope for improvisation. Then there is a wide variety of instruments and variations that exist, and they continue to evolve in the current practice. And from a community perspective, they have a large dedicated audience, continue to have that, and a significant musicological literature. This is of utmost advantage because as soon as, say, for example, we want to kind of understand what's happening in the music, there is some literature for us to fall back on. And then we don't have to kind of go and do a human-based study and then come to a study with large amounts of data. So there's already something to start with, always. And it has some unique challenges as well, right? So then, I mean, then let's look at it from the data perspective, right? So why are we kind of looking at organizing data collection? So this is an example. So if you go to Alexa, for example, or Amazon Music, or even Apple Music, the most of the organization is done in this format, right? So you have an artist, then there's an album, then there's a particular title, song that we want to listen to. So if you want to make a query, I'll say, can you play A.R. Rahman, album is Dil Se, and then some Chaya Chaya, something like that. That's the flow in which most of us are used to querying audio collections. But that's super suboptimal. So if I'm an avid Indian art music listener, I would want to do something like that. Can you play a slow Kruti in Mohan Raga and Mishra Chapatal? That's a query that I'm interested in, for example, right? So these are some things that I want to do. And then, or I want to kind of make a query, like make a playlist of Tintal Bandish that contain improvisatory sections. So these are the queries that I want to address, right? Or get other songs that have similar rhythmic passages. So some of it is called editorial metadata. So this is something that ma'am showed. It's written on the CD or whichever is the source of that music. So like, is it a kriti? Is it more the raga name, the tala name, or a specific again bandish is a form, right? So that information is editorial metadata, easy to get, and it's available as well sometimes. But what about these other ones? So what does it mean when we say slow? What is it? How do we kind of find out improvisatory sections? Or for that matter, similar rhythmic passages. What does it even mean, right? So these are certain things that are not clear, and that's the set of problems that we are trying to solve by kind of taking up MIR for Indian music. And that's where we need to complement that with data, because most of our work is going to be data-driven. So the purpose, I think one of the big purposes with which a lot of our work happened is to kind of have an enriched interaction with music. So this is with a combination of editorial metadata and content-based descriptors. Content-based descriptors are descriptors that we have extracted from audio recordings or probably lyrics or from scores that could help to kind of enhance the experience with music. And this is especially useful with large collections. So when we have large collections, if we can enrich those large collections with musically relevant metadata, and if you organize them based on similarity measures like that, right? So it's all put all the slow recordings together in some way. So then it helps us to make these complex queries to these large collections, and then that's a good way to navigate through large collections. It can help in several ways of going it. And when it comes to Indian art music, I think we saw briefly as well. With melody, we are looking at descriptors related to the raga. And then for rhythm, we are looking at descriptors that are related to the tala, right? So, well, so this is a situation that we probably want to get into sometime in the future, wherein we are looking at, assume that we make a query like this. So I go to an audio editor like which looks like that. I select a phrase and then says, this is what it sounds like, say. So this is what is called a muktaya. So essentially a phrase that repeats thrice in swaras here, right? So now I select that and then say, so can you find me these kind of instances in the entire collection that I have, which could be a few million hours of music. Then it goes and then it tries to find some examples of those, for example. It gets me this, and then it another example. So if you see across all the three renditions, they were not in exactly the same. It was not the same artist. They were not in the same raga. They were not in the same scale, and then they were not in the same tempo. And then so it was able to put together. This is of course a hypothetical example, that human search example. But we want to get to a place where something like this is possible, just to motivate, right? We still cannot do this, by the way. So good problem to solve. Yeah, what that means is the important thing here is that we need to define what is exactly that similarity that I'm looking at. So that these two points of data come together, and then we are able to kind of say that these two are similar. Yes, sir.
Private companies have, I connect the company and a million ragas in that, even if they can get 100 top score, that's a big success.
Definitely.
100 is a very difficult thing to again search for what is it that I like, but somehow they were thinking that that is a good enough solution.
Yeah, I mean, so searching through samples, right? So this is like audio search, right? So this is in fact very necessary in studio environments, wherein I'm kind of putting in studio effects for a particular video, right? And I'm laying some effects. I'm searching. So nowadays we search by say text, right? I want to say I want a door banging sound, so that I can put it on a particular video. So then it kind of gets it by editorial metadata. But if you could do that with a lot of just audio search, can I get similar sounds like this? That is possible. But then
they used to say that I'm little outdated with this. You go into a hotel or some eating place and there's some music that's playing.
Shazam.
Capture a little piece of that and put it on this application. I will get to know all the metadata as well as what are the similar pieces available, etc.
Similar pieces, I think it's still, work in progress, but exact piece, it can find it now, but that's mostly by fingerprinting, right? I mean, Shazam has this, it's not audio fingerprinting in the MDR sense, it's a rights management side, but then more of on the content side, but then it works quite well but it needs the other piece to be identical. It cannot work with covers also, but here there are different renditions, so you have to kind of just fall back on the higher level of like content-based descriptors rather than just the content itself. Yeah, it's an interesting problem. I mean, it's something, it's unsolved, and then so something to kind of look into. So that's like a long motivation series. So then we can basically, so I want to talk about music objects here, because these, and then talk about some of the MIR tasks that were not discussed specific to Indian art music, right? So as I said, the most core object for music is audio. It's an audio recording, right? It's a waveform, time sequence of amplitudes. You could store it in other ways as well. That's a core object. Then we have scores. Scores could be either prescriptive or descriptive, or they could be in, so that's Bhatkande notation, just transliterated to Latin terms there. And then of course we have the scores, right? So essentially this is another object over which we could design a data set around. Then the third thing is lyrics, right? Lyrics again play an important role in music. Then we have the last one, which is social data, which is commentary, critics, for example. So this is people talking about music. It could be in terms of artists talking about a particular piece of music, how they conceived it, how they presented it, or audience talking about how a particular concert was, or it could just even be information about what concerts are happening in the city. So all of that, this is all music social metadata. So this is found in forums, this is found in Reddits, for example, or where people are discussing concerts or newspaper columns. So all of that kind of is an umbrella term to kind of say that they are commentary critic data. That has a lot of valuable information because that's in fact has information which could be queried for finding out relationships. There might be a place where somebody has said this particular concert from 1980 reminds me of this other maestro from 1976. So now you have a clear graph connection there. So as long as we are able to infer from that, then it's useful. Right. Then, of course, we have the metadata, right? The metadata is essentially given a song name, you have all the people who have participated in that. And then this looks different for Indian music. I'm just giving you as an example, just to which it's a very good complete metadata for that music piece. Right. So these are the objects that could be a part of a data set. And then we'll see that for a lot of Indian music, so scores are hard, whereas lyrics and then metadata are available. Commentary critics are a different kind of data. So putting these all together, we can be in a situation wherein we can make a query, and then there is actually a system that can derive these relationships and then use those relationships to make a query into an audio collection, and then return back responses along with a little bit of a description of that, right? That's very similar to the way we want to interact with current, say ChatGPT type of systems, wherein we make a small query and then it gives you a description. It could also give you some multimodal output information saying this is a sample. So I say, can you show me another music instrument like the oboe, right? And then it would say, this is the instrument, these are the recordings that we have. And then these are some examples of somebody playing it. And these are some very fascinating examples of that. So it depends on, there is no end to what is retrievable, but then something very reliable and what that means is we need access to all of these kind of data for us to be able to do that and at scale, right? Okay, so MIR problems, just on the ones that were not covered here, right? So basically what we are looking at is if you go from starting from simple to complex, so these the ones at the bottom, they are more universal of sorts, which means that they could be, they are in the signal directly. They do not need a social context to be introduced for us to do analysis. But as we go further up, it requires, they are way more complex, and then they start getting a lot more subjective as well. And then they also need to be kind of infused with the information about the music culture and then things like that, which is necessary for us to infer those high level information, right? So again, this is just to say onset and pitch, for example, are simple tasks, simple from the perspective of so we do not need a lot of understanding of the music culture for that. Whereas as we go further, we need it. And then so onset translates to a metrical structure, influences a metrical structure, and pitch influences a melodic structure. So, but as soon as we do that, then we'll start reading some inputs from on the music culture. Then we go further segment on that, and then analyze patterns, and then define similarity, right? So that's the path. So why do we, so music representations here, well, they help us to kind of do kind of archive, represent, and interpret and transmit. So they can vary with content and they can be lossy, right? So it's okay to lose some information if the representation is focusing on some aspect, right? And acoustic representations. So these are the parts of the data, right? So waveforms, spectrograms, compressed audio, and then audio descriptors. And symbolic music would be, symbolic representations would be scores, and then MIDI and then piano rolls, right? Right. So again, this is a mix spectrogram that we saw already earlier. I'll just skip that. So, but again, notice how so many things are coming together here. And then the distinction here is, so you see Carnatic and Hindustani music here. And then, so at the outset, they look quite similar. But then, of course, the characteristics are, it means that there are a lot of commonalities between them. But of course, when we kind of go to a slightly more higher level, you'll start seeing that there are lots of differences. So I want to play this one example of melody extraction. I think ma'am covered it, but I just want to play an example just to see how monophonic melody extraction sounds like. So this is a sung phrase by, I think, Vignesh. Let's listen to it. So this is say a monophonic singing, right? There's you only see the here the background tanpura, which you see as the horizontal lines there. But then if what do you mean when we said melodic extraction, right? Predominant melody extraction from this. So we saw the contours that were kind of showed in the graph. So but if you were to sonify that and then let's just listen to that, this is how it would sound like. There's that blip, which is an error, by the way, right? So this is what we are trying to extract when we said melody extraction, right? So those are the little contours, and then that's a very good representation of the entire melodic sequence that's happening. Then, of course, we could use that to transcribe it into an intermediate representation and move forward. Is that so? So this is actually true F0. Yeah. If we have to move it to the next octave, of course. So with that, of course, then we could kind of talk about melodic phrases and motifs. This is again something that was described. I'm introducing this here because I just wanted to play an example of, again, a retrieval task that could be used here. And as I think it was discussed, it could be represented as these contours, continuous contours, or we could kind of discretize them into an intermediate representation, or even into a representation which people are familiar with, which is Bhatkande notation, right? So what was done here is then once we have this, we can proceed further. And these are now chunks of patterns, right? And then what if we kind of went ahead and then search for that in a huge music collection? This is the work that Sankalp did a few years ago. And then so he came up with this kind of a graph wherein you see all of those little uh, uh, so each of those nodes of the graph, they are specific phrases. And then the lines that you see, they are essentially if they are connected, it means that they are similar, right? And then of course, each color meant something there. And then, so there are different ragas here. I put a reference to the example, the work. But then the interesting part here is to listen to these examples, which is, yeah. So there are 4 phrases here that I want to play from the same cluster, so to say. So So it's the same phrase from a very vast different set of recordings in the collection, all of them coming together. And then so they coming together in a single cluster like that, right? So there are some examples like this. So that, I mean, so this work, sorry? No, this is a static image, sir. So just 4 examples that I've chosen from the graph. I can show you other examples. I can play some other examples for you. Yes. Yeah, but again, so as we said, the limitation of this was exactly what Kausa was talking about. So as soon as we start working in this kind of a granular representation, invariably we end up with like problems of how do we kind of, it's too high dimensional, and then small variations can lead to a lot of changes, right? And then, so as you said, neighboring cluster might be something completely different. So I think so. This is an example, right? So what we started was, see, we started from predominant melody, which was extracted. Then we could use that to kind of extract patterns, and then use those patterns to query a large collection, right? So we are kind of going in the same direction of we being able to kind of define similarity over large collections. So this is an example. So yeah, so that's just adding on to whatever Preeti ma'am was talking about, right? So let's talk about rhythm a little bit. Again, I think Shia is going to talk in a lot more detail, but I'll just introduce it just for us to look at some examples here. That's all, right? So rhythm, I mean, rhythmic structures, right? They are defined with again lots of low level examples all the way till something which requires much more musical knowledge, right? So the two specific aspects of onsets and tempo come into play, and then they are important, right? Onset is typically called a note event, so it's any event, and then these are basic events in time that can be grouped together and then to form other rhythmic structures like beats and bars, which I'll talk about as well. And tempo is the difference, is the pulse or the difference between these onsets, which gives us a sense of the specific timing of events in the music piece. And then onsets and tempo are not specific to music; they are also a part of our regular everyday life. So we have different events in the day, and then you could also group them, and then that's how we measure a lot of our day progressing as well, right? So this is a very inherent quality of human beings as well, to have an onset set of onsets and understanding the tempo of how things are progressing, right? So just to kind of play how onsets sound like. So most of these today, I'm not talking about how we extract these and then what use they are, but just to give you the understanding of how they look like in the data sets. So when you look at a data set and you see onset timings, this is what it means actually. So what this piece has is a set of examples. This is one example wherein you'll see that the piece starts, and then after a while, you'll start seeing clicks at the time of onset. So though you can see exactly how the onsets are coinciding with events that are happening in the music piece, largely correlated with the percussion, but then also with other notes that are being played. So you could see that there is some relative, if they are periodic or if they are not, it is very closely aligned to the structure of the patterns that are being played there. And then these set of onsets could be kind of used to kind of infer higher level rhythmic structures in the audio recording. So how do they look like in the simplest case when there are only drums? So they are exactly corresponding to the start of that sound. It's very easy to find it when there are only drums, but then it's not so easy when there is a mix of all the instruments, right? Typical onset approaches, I think surely Jia would talk about this tomorrow. I'll skip this. But basically what we get to is a detection function that will tell us, which is a representation that could be used to arrive at the set of onsets. I'll skip this because this is going to be repeated. What I want to kind of show is, again, listen to an onset detection function and then see how it sounds like. So if you listen to this, you will see that. So what I've done is I've just done amplitude modulation with a particular sinusoid on using this particular function, which is an onset detection function, right? The peaks of those are what was detected as onsets by an algorithm. But then if you just put a sinusoid on top of this and then multiply that, so whenever there is a peak in the onset detection function, you'll see an amplitude jump. So you can actually infer some basic structure from this as well. So those peaks in amplitude that you could see, they are the onset events in this. So this is again sonifying some of these things would just give us a little bit more insight into how it looks like, right? Yeah. Again, so what can we do with onsets, right? So the next would be detecting tempo. So we could just go to those events, subtract the differences between them, and then plot a histogram, which looks something like that. And then that would be an onset interval histogram, which will tell us the tempo. We could take the median, for example, and then that's a static example of a tempo. And as you see, it's a distribution. We cannot really get a precise estimate there, right? Because the tempo is not stable, nor is it actually very precise, especially in Indian art music. So this is from an example there, right? And just like the way we have the octave concept in melody, we do have a doubling concept in time. So time which is doubled kind of is perceived as the same. So if I go this, inherently the periodicity, we feel that it is quite similar, right? So that kind of gets seen a lot here as well. So what do we do further, right? So we have this kind of a tempo. Then we can actually do a Fourier analysis on the onset detection function set, right? So that would provide us some structure like that, which kind of tells us bands across, this is across time again. And then and you could kind of transform the frequency axis into a tempo axis. And then you start seeing bands at the place where there is periodicity in the entire song. This gives us time varying tempo across the whole music piece. This is how it would look like, for example, for a music piece, right? So there is a very strong periodicity here. This is again beats per minute. Well, I think matras per minute, not. And then this is across time. And then you see this is very characteristic of an Hindustani music recording, wherein they start with a particular tempo and then slowly the piece kind of gets faster and faster as the piece progresses. And that could be inferred from this. So if I were to just get a static tempo value, it will not capture this information. Right? So with that kind of a, so now we saw onsets, then tempo, then we could group these events together and then within a specific tempo and then create the time cycles, which are the basis for rhythmic organization in Indian art music, right? So what are these? Tala essentially is that, so it provides a broad structure for rendition and repetition of melodic and rhythmic phrases, motifs, and improvisations. That's a very broad definition, I understand, but then that's what it is. So if you kind of look at the structure, so you will see this is one example of a tala. This has 8 beats, so those are the numbers that you see. And then the X's, they are the start of the cycle or end of the cycle, depending on where you're looking at, because this is cyclic structure. Then you have parts which are called anga, or you could call them sections, right? There are sections in the same cycle. And then each of those sections could be grouped further into beats. I mean, so the beats could be grouped into sections. And then each of those little lines that you see, they are called aksharas. Akshara is essentially the smallest unit. Akshara is further divisible, but then that's something like a smaller unit, right? So you see there is a clear hierarchy here. You have an akshara grouping into beats, which can further group into sections, and then the sections will group into a cycle. So this hierarchy helps us to kind of layer different events in music together. And at the same time, we can use that information to infer this structure directly from audio, and which is what is the task. Again, I mean, this is in Carnatic music, equivalents in Hindustani music, where the smallest unit is called a matra, and then you have vibhag, which is section, right? So it's the same, the idea is similar. And of course, there is a huge range of tempo values that are used in Hindustani music as well. And then that adds another dimension of life. No, this is not Tintal, sir. This is Rupak. So this is 1, 2, 3, 1, 2, 1, 2. Right. So now that we have all of these things, right? So now we can actually draw some parallels here between rhythm and meter in Eurogenetic music, which is popular music also, and then Indian music and Carnatic and Hindustani, right? So there is this concept of tatum, tactus, and measure or bar, right? The equivalents of those, I mean, rough equivalents again with a lot of pinches of salt to be taken, because we are drawing equivalence just because we want to get started. Once we get started, we need to understand the main basic differences. So a tatum is an akshara or a matra, right? Then the tactus, the whole idea of a tactus it comes from working memory. It's the time on which we tap our foot to in a music piece. That's also called the beat, right? Beat is usually, depending on where we are, it could either refer to the beat or the anga, which is the sections. And then in Hindustani music, it could correspond to matra or vibhag. You see, it depends on the tempo, both it can be there. And then a bar corresponds to the avat, which is essentially the whole cycle, and then or avat, right? So if you see here, the biggest change here is going to be with respect to the beat level, which is going to be a little more fuzzy depending on tempo and then depending on the specific music piece. The other important thing here is that, so even though a typical beat as it's defined in common literature is isochronous, so which means that events are happening one after in the time interval between them are equal. That's not the case in Indian music. So people, if you play a piece in Rupak, they are not going to tap 7 times. They're only going to tap at 1, 4, and 6. So they're not going to do this for 7 beats, but they'll do. You see, this inherently the beats are not isochronous, and that's one of the characteristics of some of the talas in both Carnatic and Hindustan. And these are also have associated gestures, so which means that they are quite formalized as well. So if you want to do beat tracking, for example, for Indian art music, we have to consider that beats could be non-isochronous, and that's a requirement. And most of the current state of the art, current state of the art can be adapted to kind of meet these constraints and then solve the problem, right? So we started out with tempo estimation, then we could do beat tracking the beats of the tala. Then what if they have the beats, then we could also do inference and meter inference and tracking. So meter is the entire structure, right? So we saw, so this, if you are able to extract this whole structure of a music piece and then also derive time-aligned events of a music piece on that, so then we have solved the problem of meter tracking, right? And inference is essentially inferring what the structure of the underlying is. So tracking involves inference already. So what we want to do is given an audio recording now. So let's formulate the problem and look at an example here, right? So given an audio recording, what we want to do is extract out the onsets and then look at what are the events of this metrical structure that exists in that music recording along with timestamps. So based on that, then I can say this is where the cycle starts. These are how the beats are progressing, and then this is where the next cycle starts. And then we are laying out the entire grid of time structure for the music piece, and that is very useful for all further analysis. Like the applications include things like summarization. If I want to summarize a football match or a cricket match, you would not cut the scene at any point in time. You would not cut the scene as the ball is kind of being going into the boundary. You would cut it at the place when the bowler is actually taking a run to bowl the ball, right? So that's an important event that needs to be captured. How do we capture that automatically? So that it provides you that. It provides anchors for segmentation of the audio recording. So, I mean, that's one of the examples of applications. So let's listen to this. So what's done here is, this is a piece by Vidushi Bombay Jayashree. It's in a Tala cycle, which is of 3 beats. So 1, 2, and 3 beats. And the entire cycle is divided into 12 subdivisions, the aksharas here, right? So you will see a click on the X and 2 and 3. You'll see 2 different clicks. So the click on X sounds different than the click on 2 and 3. You'll be able to tell. I'll kind of show you where X's are, and then you can listen to the other 2. Yes. Classification?
Yes, because according to the proposed searching.
Right.
So classification is going to play a vital role.
Classification of talas, you mean?
Any.
So I'm calling the task of tala tracking to include a component of classification, which means that you take an audio recording, you classify it to which tala actually it belongs to, assign a label essentially. Once you assign the label, we also need to assign events and on where exactly what event is occurring. So the classification task is implicit in tracking. Yeah. Yeah, this was, I mean, of course, at least this work was largely supervised. So because we would have labels associated, but then when we are working with large collections, we might have to we'll not have labels to verify anyway. So yes.
X is the summer, right?
Correct.
There are different weightage.
In this, no. In the recording, no. In general, they could have. In this case, it does because there are 2 vibhags, that's all.
No, the 2 is like older and like longer than 3. Is there any significance?
Yes. I mean, for Rupaka, I mean, this is a very kind of simplified Rupaka. So otherwise, if you take the Carnatic older Rupaka, the first beat and the second 2 beats are different. They have there's a clear vibhag division because you have gestures, right? So the gestures change once you move to the second beats. Yeah. Yeah, I mean, I just copied, I just took that idea and then put 2 here. But this is called the Rupaka Chapu, right? So Rupaka Chapu doesn't have 2 and 3 to be different.
Is it because we tap on 1, 2?
No. I mean, so the traditional Rupaka is actually a 6-beat cycle. So it goes 1, 2, 1, 2, 3, 4. So that's why you see the first one is a Dhruta and then you have a Lavu. So that's why you have this one gets broken here. But then this specific structure is half of that. So technically it doesn't have it, but then if you want to compare the 6-beat into a 3-beat cycle, then you will see that kind of a structure. Yes. Yeah, it is.
Or if you look at like Latin American music, it has the Tresio 3/3
Correct.
thing, right?
Yeah.
Like, so there like they also use similar algorithmic techniques which you are going to be talking about.
Yes. So see, so in the metrical structure, there is going to be that difference. But I mean, so one of the inherent assumptions were that they are isochronous. So even in this case, right, you can always, if you keep going further into a common factor, we'll always be able to find a common factor time, which kind of covers all the events. So that's the basic time. So it's like second, no?
For example.
Yeah. So I'm talking about the smaller units. Say take a clock, for example, right? A second is equal in all durations. But then I might take that 60 seconds and then divide it in however way, right? And then I might say this is my unit. So 5 seconds is unit. And then in another place it's 10 seconds.
Akshara in this case.
Akshara. So at the Akshara level, you still have isochronicity. That's why you see all of those lines are equally spaced. But if you go to Vibhag level and other levels, that's when the non-isochronicity comes in. And the important different distinction here is the foot tapping time is a non-isochronous. So you would not tap your foot on all those aksharas, but at these 2 and 3 places. And that exists in jazz, for example, as well. Yeah, it surely does. And then that is where there are limitations of beat tracking algorithms. So if you solve it in Indian music, some of it could be kind of translated back to jazz and all vice versa. That's the idea. Yeah.
And another question was when you showed the pentagram, it had like one area highlighted. That was also done in the same way as the extracting the main melody out of the spectrogram, or like
kind of. Well, I mean, that was just a dynamic programming approach to locally find the peak and then track it through the entire piece. So it's almost like it's like a hill and then you're climbing on top of the hill all through. So
across each like segment.
You can take,
like
so exactly, that's the easiest, but then you also have to ensure that you are maintaining continuity.
Yeah.
Right. So you have a continuity score and then you have a peak score and then you adapt that together to find the local.
The name of the algorithm used?
Well, it's any deep dynamic programming. You just set up a dynamic programming cost function. And then based on that, you trace, and then once you hit the end, you trace it back and then you'll get it to the same place. So very common.
But like where there are gaps and stuff, it can create those like deep like errors which you had shown in the manual.
Correct. So that is where I think, so this is a good example, right? So you will see, so this one did not have, even tempo could have doubling errors. So suddenly somebody might just play a very quick series of drum notes.
Peak might be there and then it might jump.
Yes, that's where continuity matters. So it's a trade-off, right? So if you break continuity, there is a cost associated. If you break moving to a different peak, there is a cost. And the whole idea is to balance those two so that you get a continuous curve. Yes. Yes, it does. Yeah. I've not shown the harmonics there. And that's exactly the doubling, right? So you will see a lot of harmonics and we want to track the fundamental. The idea is exactly the same as predominant melody. Yeah, except that you are operating at a different time scale. It was not the same. I mean, this was a little more simpler, but you could use anything that kind of tracks continuous contours in a piece of music. Yeah, same idea. Okay, let's listen to this.
Shankari nive Amba Shankari nive Amba Shankari nive Yaninu santatamu kori vajidi Shankari
this was a 3-beat cycle, right? So next we have a good example. So now let's try and participate in this. Kaustubh, you are out of the game. So everyone else can participate. Now, so this is again a Hindustani tal, again in Vilambit Ek tal, so which is a cycle of 12 matras. That's the structure of the tal, right? So I'll play and then I'll start off. You will hear it starting on the sum. So it starts here, and then let's see how it actually progresses, right? That's the first sum. So here. Sorry. So where did we actually stop? Anybody noticed? It's Vilambit. So where did we stop? Which part of the cycle did I stop the recording? Yes. So that's the challenge I wanted to bring out. So Kausu will know where we stop. We stop. Right. Where did we stop, Kausu? 3 here. Yes. Yeah. So you see now, so you saw the previous example is also a tala. This also is a tal. Then you see the big difference in this order of magnitude longer than the previous one. What that means is there's a working memory in the previous case, which helped us to track cycles much more easily. Here, the length of the cycle is just outside of our working memory. And then that causes a lot of challenges, both for humans and for machines. Yes, sir. Yeah, in Carnatic music, both the musicians are playing the composition together.
Almost what I have heard. Why is this thing?
It's because of something like this, exactly, right? I mean, so now you need an aid for us to, I mean, as a musician, you do not have to rely on tabla, for example. You would already be knowing the cycle in your head. So Kausu has that skill, for example. You talk to him, he can track these kind of 70 seconds long cycles without actually losing track of. So you kind of have him track this for 40 minutes, then he can exactly tell you which part of the clock, that cycle you are in, right? So that's something to develop as a professional musician. But for other listeners, there is a tabla which is actually playing a particular simpler theka pattern, which tells us which part of the cycle we are in, and that's how common people can understand what's happening there. And with Carnatic, of course, because of the difference here, right, wherein the entire cycle is in a working memory, and then people can track it. And there are gestures to show which part of the cycle we are in. Even there are longer talas in Carnatic music, but then there are gestures to show how the cycle is progressing. That's when both the musicians, in fact, it's not completely true that the mridangam is following the vocal artist or the lead artist, but both of them are playing the same composition together. So what that means is, I mean, technically you could, so both of them are playing the same thing. So you could also have this, have kind of say that mridangam is following the main artist as well.
Because the other melody artist, the violinist, is following the main artist. So
that again, I mean, in principle, they also should be playing the composition in the best possible way as an accompaniment. It's the same with mridangam, but you could kind of, it's to say they're all related, right? What is not important here is the tala structure is not maintained by one particular, there is no role that somebody needs to keep the tala, but because there are gestures, there are these kind of mechanisms. So that's the big distinction here as well. Yeah. So this is a problem for any tracker right now.
Behavioral studies, like they usually show, like at least in the West, they've been done, like the perceptual threshold for like guessing a beat is somewhere around 30 to 33 BPM, while Vilambit Tal can go down to 8, 10, 12 BPM, which is the problem we were talking about.
Yeah,
It's beyond the perceptual threshold of a beat. Like it can be trained, obviously, like you're saying, but
no, that's what
true,
of course. That's precisely the problem I wanted to bring out here. So now if we say that we want to do meter tracking on this, we need to remember the entire structure here, or kind of break it down into substructures and then track them separately. So, so the problem formulation is not exactly the same for the previous example and this example. That's the basic distinction, right? Okay, so let's kind of look at the data sets that we have, right? So this is another example of structural segmentation. So if you have the entire music concert, you could break it down into different pieces. So here you have two examples, Kriti and percussion solo. This is an application of rhythm analysis. If you have the entire transcribed tracking done for the entire concert, we could use that to break the concert into different segments, which are more meaningful here. Let's start with data sets here, right? So just to kind of see, the main idea here is we are, so that the basic idea of building data sets is we try to build multiple kinds of data sets. So broadly, I could classify that into research corpora and test data sets. So I'll talk about what they are. And they are essential for data-driven MIR, right? And just building the data sets is a research problem in itself, right? How do we build a data set is a research problem that we need to solve. And in music especially, it also means that we need to involve communities. This is something I kind of already talked about, right? I mean, and then of course, data is also the is a very critical component of most of our current machine learning approaches. So this is something that is paid a lot of attention to, and rightfully so if you are doing data-driven work, right? So let's talk about this distinction, right? So we are in some kind of a real world. There is something outside of the real world also. So but then yeah, let's just focus on the real world. Out of that real world, we create a sampling and call it a research corpus, which is as representative of the real world as possible. It's a subset. And out of that research corpus, typically, we also build test data sets. Test data sets are data sets that we build for specific tasks. A corpora is built for a music culture for us to do several things with that. Say we build a Carnatic music corpora, and then within that we create smaller subsets of data, so which we could use for beat tracking, meter tracking, or predominant melody estimation, things like that. The thing to note here is test data sets could be a part of the research corpus. Largely they overlap, but they could also be from the real world, right? Externally, it need not be a part of the corpus. And it could even be synthesized in some cases because we need it for our application. So that's the distinction I wanted to draw. It need not even be real world. So you could create, say, an artificial tick data set for us to evaluate some rhythm tracking approaches, for example, right? So I want to talk about some fundamental principles here, right? So two broad approaches and two broad things that we kind of considered at least to build our data sets. So the systematic approach to building MIR corpora involved multiple dimensions. So I think one of the papers, Javier Serra, that he wrote, talked about these 5 dimensions to build a data set. So whenever we are building data, ask what the purpose of the data set is. What is the coverage that we are looking at? Coverage means what are the concepts I want to kind of look into, and then how are we covering all of those? Then among the ones that I want to cover. So say if I say Carnatic music, coverage talks about, am I covering all the ragas, for example, and all the talas which are performed in practice? And then comes the completeness. So completeness talks about, given a particular audio recording, do I have all the data that I need? So it's possible that this is the missing label problem, right? So if you have a data point, so we need all the labels that could be associated with that available or not. If we have it, then it's complete. Otherwise, there could be missing things. It's possible. It happens when I have some annotations done, some annotations not done. So we give it out to different sets of people to annotate. So they kind of return back, so partially annotated data sets, right? So that talks about completeness. This could be objectified, by the way, and then we could kind of come up with objective measures for each of those. And quality is essentially the quality of the labels that we have and quality of the metadata we have. And finally, we also talk about reusability, right? So can it be reused? And then can it be reproduced? Can we actually reproduce our experiments, which we did using this data set? So these were some 5 tenets, and then based on some reliable references to create this data set. There's another way to look at it, right? So this one does not specifically talk about using it for machine learning. This is in general true for most data sets. If we bring in machine usability or machine actionability with the data sets, then we stumbled upon these FAIR principles. So FAIR stands for findable, accessible, interoperable, and reusable. So these are the tenets. So what's the basic idea here? Findable means the metadata that's associated with the dataset allows us to discover this dataset. So if I don't even know that this data set exists, it's pretty much blind, right? We are flying blind. We really do not know what we can do with it. So the available metadata allows us easy discovery. What this means is the data set is searchable, the metadata is indexed well, so that when I search for it, so it's usable, right? So say, for example, Zenodo is a very good, if you put your data sets on Zenodo, it's a very good findable data set. Then once it's found, we need to have access to that, right? So access talks about, can I access this data set in the most easy way, for example, through APIs, for example, or some specific part of the data set if I want to access, is it possible to do that, right? So that's the accessibility. Interoperability talks about, can I integrate these data sets into an existing framework? Say there is a framework called MIR data right now, right? For example, which is a repository of lots of MIR data sets. Is my data set interoperable with that library, for example, as a quick example. So which means that the MIR data like API could be used to access this data set, which automatically means that multiple data sets could be pulled in together into your experimentation. You could publish results on all of them together and so on and so forth. Another example is, say, Hugging Face, right? So you have a clear way of accessing all your machine learning models through that. And then you could just use one Python script to test out so many different models. So that's an interoperable way of storing data, right? And reusability, I think we understand it well. What we do not understand is how optimal and how easy is it to reusable, how important reusability is. This is one of the factors that's being increasingly getting a lot of attention in the community as well, on data sets being reusable and reproducible. The optimal reusability. So if I'm, it's more about this one talks about open availability of data sets, so that I mean, if I use it and then I do not have a very easy way to kind of make it available to others, then it's no longer reusable. So yeah, yes, it's reusable by the community, open. Yes, yes. Right. And additionally, I mean, these again, those FAIR principles do not talk only about this. So here specifically, if the code is open source to access this data and the data is easily accessible, that's when the maximum use of that data is available. So these were some tenets, right? And then, I mean, of course, when we talk about availability, these are certain best practices that we at least try to follow. So wherein there is a way to visualize and look at data for casual immediate users. And there is a way to kind of access that data programmatically integrated into our experiments. Then when it comes to all the data that we have, audio, typically we usually look at either commercial audio, which could be bought, as hence it's accessible, and or open audio collections where we have licenses to use them in our experiments. And that's for audio, but extracted features and software, they are all released under open licenses so that anybody could get access to that. And editorial metadata is kind of very clearly identified and stored, and annotations are publicly available and mainly archived on Zenodo. Zenodo is a good platform right now. So that platform itself might keep changing as things progress. Every 10 years, we have a different platform, but the ideas still remain the same. Zenodo provides a document object identifier, digital object identifier for every thing that we upload there, which could be easily used to identify a data set. Right, so these are the data sources. I think we talked about this. So then let's look at some general data sets, right? So million song data set is one that's available. It's a common data set since about 10, 12 years now. Yes. They were, I think some of it is digitized. I think People has a project with Prasar Bharati. Yeah.
Some old archival vinyl record they have this. Yes, they donated us also a big charter and all that. They didn't allow some major to donate.
It's the perfect example for everything that I talked about today. So the All India Radio collections. So yeah, so that's in fact it's a public resource, and then somehow it's not available very easily because to us. I mean I do understand the copyright here, but then if it could be made available in a streaming way for people who subscribe, and so it's possible to, there are mechanisms to kind of make it available. And it's in fact the perfect example of like organizing data sets through descriptors here. So million song dataset, it's a very popular. I'm just listing, this is a generic datasets, not specific to Indian music, but then they are a good example to start from. So if you are looking at, so the idea of million song dataset was that the audio itself is not available, but features are. So which could be used to build like so ML models, for example, right? And similarly, the idea was music brains and acoustic brains comes in. Acoustic brains again is similar. Only features are available, but then this is crowdsourced, so community contributed, right? Then we have free sound, right, which is Creative Commons sounds. So this is not music, but then sounds. And then this is again a way of kind of sharing audio. So this is where I think audio-based search would be directly applicable. So we have short snippets, and then can I search through audio examples rather than text-based search? Right, let's look at the Indian music data set. So say, for example, Music Carnatic corpus here, right? So it contains, again, as I was describing, it contains audio, then a lot of metadata, lyrics and scores, and community forum discussions, and then an ontology of music concepts. This ontology ties some of these things together so that we exactly know how to connect these elements together with when we have a specific set of recordings, right? And if you see, though, the audio, metadata, and lyrics are the artifacts, and then we have contextual information that puts them together in a nicer way through these ontologies and community discussions, right? Similar structure with the Hindustani corpus, right? The idea is similar. And then we have, so with those two are the broad corpora. So, and then we also have data sets here, right? So those data sets are all again available on Zenodo. I'll just go over some of them, right? So these data sets were created for specific tasks. So we saw tonic of a music recording is an important aspect to extract because that forms the base note. It's the equivalence of finding the period of an akshara within an audio recording, right? So the rhythmic equivalent. So we have data sets that could extract tonic. Then this Varnam data set again was a collection of solo recordings with transcribed notes. Then we have the rhythm data set, Hindustani and Carnatic music. I'll show an example with that. And then we also have percussion specific data sets, right? So Mridangam stroke data set and tabla solo data sets. These would help us to do percussion based analysis. So you see each of those individual data sets, they are made for a specific task. And then they are well annotated, and then they are well cataloged in Zenodo, for example. So they could be uniquely identified. And so whenever anybody uses it, so they could also contribute back to the data set, and then that's how it grows. And then Zenodo has the mechanism to add new versions of the same data set, then make it available as well. Right, what I want to kind of do here for like a few minutes is just to go over the Carnatic music rhythm dataset as an example of what is there in this, and then what could be inferred, even without even going into a strong like or even a detailed analysis through a machine learning system or even a signal processing system. This is just looking at statistics of what's there in the dataset. What are the insights that we can actually arrive at, right? So the Carnatic music rhythm dataset has essentially audio recordings and whatever you heard, right? All those clicks. So they are annotated. So timestamps of each of those rhythmic events are present in that dataset. So just to give you an example, so you see that's the number of annotations that are there in that dataset. It's about 16 hours of data with about 120K annotations, right? And then among those, so this includes also beats. This includes only the cycles. So it has 22,000 cycles of music, right? And then, so if you kind of look at some basic idea here, if you do some basic statistics on how these recordings look like. So what I've listed here is look at this data point is very kind of interesting. So this talks about the length of the cycle in the data set plus some bit of standard deviation shown here. And then this is the mean again, and then this is the standard deviation, right? What's interesting here in Carnatic music, this is what I was mentioning in the past as well, right? So if you notice the tau zero here, which is the akshara period, they are quite similar, even though the cycle lengths are longer and shorter because because the cycle itself has more matras and aksharas. otherwise it's very close and similar, right? And what that means is the entire tempo range for Carnatic music in current practice is quite limited. So people, that's mainly because there are gestures associated with Carnatic music when it's being performed, and then people are comfortable with the specific tempo at which you can demonstrate gestures. That's why you see a very tight range of akshara periods across talas. Now this is across the data set as well, right? So you see it's quite tight, and then even the standard deviation is low, right? That's compared to Hindustani music. If you see this for Hindustani music, it would vary a lot across, right? So that's what we see. There's not a lot of variance across different talas, and then of course, so that's something to infer, right? So this is like just looking at the durations, you can come up with some musicological insight that could be kind of verified as well, right? Then if you kind of just plot just the histogram of those, and then look at what's the variations that you can see, right? You'll see that in the median beat duration with Carnatic music, in the collection that we have, the deviation is not more than 20%. So there is, and then this is even shorter if we consider Hindustani music. So what that means is Carnatic music has a little bit more expressive timing when it comes to specific compositions compared to Hindustani music. Hindustani music, you will see that this is even more tighter. So here there's a little bit of spread. It gets tighter in Hindustani music as well. So very simple interpretation just from that. Then we could actually compute what are called average representations of a tala cycle in each of these cultures. This is an example for Carnatic music. What we did was we used the beat and the downbeat annotations or sama annotations, and then we took the spectral flux, which is a feature I think Xiao is going to talk about tomorrow. It's a feature that was used to generate the onset detection function. You saw those onset detection function, right? So we chop off that at the beat and the downbeat markers, take cycles, and then put them on top of each other, just add them up, right? That this gives me an average pattern of a tala in a cycle, right? So if you see, that's the structure of, so let's look at these. There are 4 different talas here. This is the tala of 8-beat cycles, 8-beat cycle. This is the tala you heard, right, Rupaka. And then these two are other 2 talas, right? You can see that at each beat position, the taller the particular data point, the point here is, it means that there is a strong accent at that particular place. Either that could be coming either from the percussion or from melody, either of them, right? And then we could see, so the structure of the tala as it's taught to us in music learning, some of that could be inferred here. So for example, this is the cycle of 8 beats. They say that the 5 and 7, 5 is the half cycle, right? And then 7 is about the second part of the half cycle. So those 2 are accented beats of the tala. And then of course, sama is the strongest. If you see, sama is the strongest everywhere, except in Rupaka, which I don't have the example here. But then essentially, if you see, these are certain things that you can directly infer from this. So in addition to that, I can see some other beats to be quite more stronger. In a 7-beat cycle, even though we want the downbeat or the sama to be the most strong, it's actually the 4th beat that's the strongest. So it's so 1, 2, 3. That's the anchor sometimes, because now we have non-isochronous beats, and then we need an anchor, and beat number 4 acts as that. So these are some things that we could infer directly. This is common knowledge, but then it's also seen in data. So then it helps us to look at these and then validate some of the other musicological claims directly through this, right? So I just want to finish by talking about Saraga, which provides us, which is, so we could not solve the problem of copyright here, right? So we do not have access to large music collections which are open. And that is something, there are efforts elsewhere, but then music labels still own copyrights over a lot of music. So this was something as an effort which is useful. And then because now we could use this data set for a lot of other applications as well. So this is called Saraga. It's the largest annotated open collection for Indian art music. And then I think several of you are already aware of it, and then you're using it in your work as well, right? And shared under Creative Commons. It has audio and editorial metadata, uniquely identified. It has all the characteristics that we were so far talking about. It has both manual and automatic annotations, right? So that's the statistics. It's not very big again. It's about 43 hours for Hindustani and 52 hours for Carnatic music. And the important part is the sum of the Carnatic collection is in multi-track. This is also what Rajesh used for his work on source separation for Carnatic music, right? So content, again, recordings from concerts, and then it has editorial metadata, which includes name, composition, involved composer, artist, and the role they played, raga, tala, and the form, right? And then annotations. So the audio is under Creative Commons, so which means that there are some restrictions, of course, to use it. You cannot use it for mixing it and then putting it out there as a different so Creative Commons licenses come with their restrictions, right? Yeah, but editorial metadata and annotations are publicly available. So essentially CC0, Creative Commons 0 there, right? So we have manual annotations for sections, summa, tempo, and the characteristic melodic phrases in the audio recordings. And we have automatic annotations for predominant melody and tonic. So there was an algorithm that was run to generate that predominant melody, and it's a part of the dataset, right? And then we organize it based on the same set of tenets, so giving easy access to human and machine consumption. We want the data to be open and the code to access it to also to be open, and then emphasize on reproducibility, and then easily so that it could be easily adopted by both researcher and listener community. So it could be used for listening as well. And most importantly, enable community contribution. So if somebody wants to add their collections to Saraga, they could do it, right? And then of course, the organization is similar to other data sets. We have an audio recording and all the associated metadata sits around it, right? Yeah. So it could be accessed through an API, and then which could be used to fetch metadata on audio separately. And then it's version controlled through a publicly available repository. So it's on GitHub, essentially. There is a website, I think there's a link to that. It could be used. There is a lot of information there. Again, I am just kind of mentioning it here so that so you guys can help it grow and then sustain further. So add more data to it. If you are working on that problem, if you want to add more annotations to it, please add it so that it's made available to everyone, right? Okay. Well, a couple of places where it has been used. It could be used for several MIR tasks, surely. And then it has already been used in Musical Bridges project, which was about understanding and appreciation of Indian music. And then it's also as accessible as a part of the Saraga app. So this is a way to kind of, so that's a visualization of an audio recording. And then you could see the tempo and the tonic here, and then different sections of the piece. These little lines that you see at the top, they correspond to the Tala cycle. So it's a way of visualizing the whole music piece there. Right. So this is, again, all of this could be put together into an interface like that for music listening. And then, so that's the platform is called Dunia. It's available as well, right? Okay. So let's start on, proceeding further on that, there is a current opportunity that this is some problem that I and Kausu are currently working on, which is to kind of build this application for enhanced discovery and listening of Indian art music, but on curated collections of music. So this again circumvents the copyright issue, wherein we do have a lot of personal collections at our homes, so sitting somewhere. So, I mean, at least the ones who are started collecting music on their hard disks, right? So that generation at least has a lot of music on their hard disk sitting, but then they are not organized in any particular way. So that could be a very good example of how we collect. So we want to get from listening to music to enriched listening, wherein we add and metadata to it and then enhance it. Then to guided listening, wherein there is a clear pathway that we could take through these collections. This is on a single collection, right? So I have a single collection. Now I have a guided listening tool that helps me to navigate through this collection, suggesting me things. Enriched listening is I know what I'm listening to. I only get additional information. Then we want to get into discovery, which is that of now I have multiple collections, and then how do I discover how to actually navigate through the set of collections? Then comes the interactives, wherein we want to interact with that collection, add annotations, and so it's all different levels of our engagement with these collections, right? That's the basic idea. And we want to get to a state where we are able to combine audio, text, and symbolic representations together. This is essentially a multimodal type of system that could be developed out of this. So get in touch if you are interested in learning more about this. Right. So last 2 minutes, I just want to take upon some opportunities in India that exist for MIR. This is not related to the data sets, but then something I just wanted to kind of emphasize here. Now we are in WiSSAP, and then it's relevant. So again, this is something that we talked about, different times, universities and institutions in the country, academic institutions that are helping with MIR grows, you see this number is growing rapidly, and then it's good to see that. And of course, there's a lot of industry presence also within India. Do you need a picture of this? Yes. This is non-exhaustive. Again, if you don't see your university, please come to me. I'll add it and then present it in the next talk. Yeah. This is not comprehensive. So yeah, I had forgotten to include IIT Mandi. I saw Rajesh and then I added it here. So you please come and talk to me if you see something missing. And industry again has a lot of presence in India currently. These are the companies that have some good presence in India, music tech companies, not necessarily Indian music. And then one of them is in fact also, so ma'am was closely involved with Sensibol. And then so Javier Serra was closely involved with Music Muni Labs. And then so it's from alumni of UPF, for example. And Beethoven is a recent generative music AI startup, again, partly from MTG and then from Georgia Tech. So there is a lot of scope. And then the 40-year-old Radin, I think pretty much anybody who plays Hindustani music or Carnatic music is aware of their products, right? So there is sufficient things that are growing up. And there's a big community. I think we talked about ISMIR. There's a mailing list if you want to join and then kind of get aware of the activities. There's also a ComMusic mailing list. So that's possible as well. And then if you want to understand where the field of sound and music computing is going, that roadmap is quite good. It's again a little dated. I think there was are you aware of a new version of this? Yeah. There is a roadmap that was created by several senior MIR researchers. This was a few years ago. Now, do you know of a new version of this? Okay, yeah. ISMIR website has a list of labs as well across the world. And then I think recently, few years ago, started a music tech community in India. This again is not specific to Indian music or MIR. This is in general a music tech community, mostly people who are makers, they want to build things around music. And then so there is a set of people who are doing that. So go to that address, you'll see a lot more information. If you want to learn, I think this is a course on Coursera offered by Javier. This is a good starting point if you want to learn a little bit more about music applications, signal processing for music applications. Then if you want to learn more, the best starting point is ISMIR tutorials, right? And then there are several resources available as well. And this is the Spark monograph I was talking about. That's again available as well. Yeah. Okay. Well, if you want to build and contribute, there are a lot of hack days that keep happening around the world. And then there is also one hacking event that happens in ISMIR conference every year. There are lots of tools and libraries available if you want to kind of build, right? And then of course, Mirex hasn't happened in a few years now, right? Yeah, so this is dated now. So there used to be so MIR Evaluation Exchange was a place where there were a lot of MIR tasks, and then we could submit our approaches to be evaluated against standard data sets. So it's not happening for a few years now. Yeah. And if you want to meet people, WiSSAP is a good place, as you know already. And then ISMIR conferences are good. And Music Tech Community India is also a good place. So there is an upcoming event, not fully related to MIR, but then a good place again. It's the Audio Developer Conference. And it involves a music hack day as well. That's happening January 5th to 7th in Bangalore. So please check it out if you're interested. Yeah. So that's mostly what I want to talk about. Yeah. Thank you. Yes, sir.
Just give a little bit of a recognition of their reward as a reward, just recognition. Many contributors, especially music learners, would like to, even if they do falter some mistakes, etc. They also want to not only learn the classical music, but maybe a little bit savvy about using technology.
Right, sir.
Is there a way to reach them out? And there are thousands of them, schools and teachers. Teachers should be reached out first.
Yeah, I mean, in fact, so those are the outreach initiatives that we need to. In fact, I saw it's in fact Google is building a set of tools to record and then build those data sets as well. So there are efforts. So there is that's the community involvement. So we haven't found a very good model for that involvement, but then so definitely open to discuss and then add data to that. No, that's true, sir. In fact, the whole Saraga was an initiative like that. We went to specific musicians, we requested them to share some of their recordings, and Kausu and Vignesh and Preetma, everyone helped there to source out these concerts from them, which they kind of very gladly gave it to us, saying you could use it for any purpose with under Creative Commons, and then we annotated it. So that's why you see that's a starting point. Then needs the community contribution. If somebody sees I have 100 hours of music, I want to kind of add it to the Saraga, I'm very happy to kind of take that forward. Yeah, yeah. Yeah, we could always filter later, right? I mean, so add and then filter. Yes.
Sorry, that's a good question.
Yeah, no problem.
You mentioned in the start, like music technology, how it can help in lot of ways and all. So you highlighted a few things under MIR, you highlighted a few things under ethnomusicology, and two things you did not highlight at all, which were production and performance.
Yes, I had another slide which talked about creators, and then that's where it was highlighted. Sorry, again, you got it as a producer, right? So, well, I mean, surely, so for me, that's a very big industry, and then that's where the ADC conference comes in. There's a lot of producers who come there, right? So it's a very established industry, and then we can, of course, there's a lot of things that could be kind of helpful with MIR from there as well. Yeah. But again, I'm not the right person there, not an expert in that. So yes, yeah.
About the product tracker which you mentioned. So we don't know that the products are not as diverse as the others. So, and most of them fall under the four main products.
Correct. Yeah.
So can't we just group all the products and see which one falls into this? At least that's the naive solution.
Sure. I mean, that's how some of the people also do it, right? They try to force fit so Tala is a latent structure in the head. It's not, so it's possible, yeah. As you said, number of options are limited. Sure. True, sir. Yeah, well, this. There is at least 35 defined ones, like structurally like Melakarta equivalents. Then there are 108 ones. So, but this is, I'm just talking about practice. So rather than theory, yeah. Ontology, some knowledge graph. And rasikas.org, it's a forum, yeah.
So, do you think, I think that is one of the biggest challenges right now, like Sir was just riffing on what Sir was saying that, and what you were also saying, like, some people have 35, like groups, some people have like more, and there's like what do you think is the lack of contextual information? How do you think like that can be combated, or is there something which we should just grab onto? Yeah, okay, this is fine then. Like this analysis, let's just go around this and build on top of it with like computational tools, or do you think we should focus more on like uncovering all the previous ethnomusical work done and combine them in some sort of way? I don't know if there are courses or if there are very like bibles of this contextual information.
Yeah, I mean, it's a hard problem, right? I mean, so again, so the musicological literature is quite vast. And then, so I would take an engineering approach here. I would use whatever I mean, I'm not an expert, so I would not go and then reinvent the entire or kind of rediscover some of these, but then collaborate there involve the community to get whatever is the formulation I need for solving an engineering problem. So that's also the industry approach. So right, I mean, so that's one way to kind of solve something like this. So if I don't need the 35 talas to represent my data set, I do not need to kind of go and then do a lot more work on that. But as an academic understanding of like how the music has evolved, it's good to understand that and then understand the structure of those. But if you do not have data for that, it's as good as like it's not something that you would do as like it would be necessary for doing the initial set of work. But there needs to be that scientific work in parallel as well. Right? It's mostly community collaboration which will drive all of these. It's hard to do, yes.